So far, there are two Opentox gadgets on Garuda, which is the OpenTG-Gates sample finder and the OpenTG-Gates data fetcher, and both of these talk to the Opentox OpenTG-Gates API. So we can launch them by double-clicking, and normally an analysis will start with the sample finder, though it's not the only way, but it's the typical way. So I start by double-clicking here. Now, if you didn't know, OpenTG-Gates is a famous toxicogenomics database developed by Japan's Toxicogenomics project, and its content is mostly famous drugs and toxic compounds which have been studied in a considerable depth, in the sense that every compound has been studied at multiple time points, multiple dose levels, repeat dose, single dose, various tissues, and both rat and human samples, vivo and vitro, in a consistent way. So it's very useful in theory for many kinds of cross studies and for elaborating and elucidating toxicology mechanisms. For this study, I will select 24 hours high dose acetaminophen, liver, rat, in vivo, single dose. If you like, you can select multiple parameters by keeping control pressed or command if you're in Windows when you click on the parameters. So I'm going with only 24 hours in high dose. When I'm happy with my selection, I click Launch in the lower right corner, and then it talks to the API, and it retrieves a table with my samples that match the criteria. Now, with these samples, you can send them on to other gadgets in order to retrieve the gene expression data and do more interesting things. I just want to mention briefly before I go on, you can export data from any Garuda gadgets out of Garuda, and the way to do it is you click the Discovery button. So Discover is a button that's present in almost every Garuda gadget, and it lets you discover other gadgets that may receive data from the current gadgets. And you make sure that File is selected in the top corner first. There are two kinds of discovery, and we want to do a file discovery. You click Discover, and then you double-click the NAND file gateway. The NAND file gateway can receive data from almost anything, and its purpose is to export data out of Garuda. Now it receives my table of samples here as a CSV file, and by clicking Export Now, this can be saved as a file somewhere. That's how to export your table. Now though, for my next step, I want to fetch the gene expression data, so I'm going to change the discovery type to Data in the top right corner. Then I'm going to click on the sample data, sample ID, to select the sample identifier codes. Now, if you want, you can select multiple columns, but for this step we have to select only sample ID. That's important. And then I click Discover again, with data selected here. And then I'm going to see the OpenTG-Gates data fetcher as one of the choices. I double-click that. Now that is the other Opentox gadget, which is going to receive gene expression data from the Opentox API. Now the inputs we just received, it's going to ask us, do you want to treat this as a sample list or as a gene list? So this is obviously a sample list. And then I have to also assign a gene list in order to have both samples and genes defined, and that will be the basis for the matrix of expression data that we're going to retrieve. Now, if you have a text file with gene symbols that you already care about, then that can be your gene list here. And then you just double-click and you select your gene list text file. If you don't have such a file, or if you want to retrieve all genes, then you must select an empty text file. So I'm going to double-click, and I'm going to select an empty text file. And that can be created with TextEdit if you're on Mac, or with Notepad if you're on Windows. Or it can be, as I said, a file with gene symbols if you already have genes you care about. Now that you have assigned both of these inputs, you see a file name for sample list and a file name for gene list. Then you click Launch in the lower right corner, and it's going to talk to the Opentox API. So after a little bit of waiting, we get the data from the API. And now we have actually all the genes for these samples, which is 31,000 plus probes in that array. You can see the Affymetrix ID of the probe and the gene symbols, if any. Some probes have no gene symbols. And we can see the log2 fold value for the sample and the p-value. And then here is another sample and another p-value. And finally the third sample and the third p-value. Now this table can be exported as before by clicking Discover and selecting the NAND file gateway, and that is a file discovery. Another thing you can do is, in this table we can filter by p-value, and the way to do that is in the lower part of the screen where it says sh run sh algo gbuilder table and so on and so on. At the end we can type a number such as 0.01, and that will be the p-value limits, and then we will only get those genes that have this p-value or smaller. I type that and I click launch, and this is going to be quite a bit faster. And now I have only those genes, a few hundred or so, that have this p-value or less. This gives us a rough indication of what are the significant genes for those samples at that time point and dose level. So in the next video I will move on and show how to use this gene set we've just discovered and do a downstream analysis based on these genes.